Today we're going to talk about Gibbs phase rule. So this topic is being discussed in many chemistry subjects like physical chemistry, general chemistry, and napag-uusapan din ito sa thermodynamics and chemical engineering calculations. Makikita din natin to ginagamit sa ibang unit processes or separation processes. So mas maganda na mapag-usapan na natin ngayon kung ano ba yung Gibbs phase rule bago tayo mag-proceed sa iba pa nating mga topics. So first, let us see kung ano yung definition ng Gibbs phase rule according sa mga textbooks. So Gibbs phase rule is the number of intensive variables that must be defined to determine the state of the system. So we're going to explain that later. Tignan muna natin yung iba pa nating mga definitions. Gibbs phase rule is a definite relationship in a system between the number of degrees of freedom, the number of components, and the number of phases present. So as you can see, the relationships between the degrees of freedom, the number of components, and the number of phases is given by this equation. So F is equal to C minus P plus 2, where F is the degrees of freedom, C is the number of components, and P is the number of phases. So, ano ba itong tinatawag nating degrees of freedom? Well, this is also called the variance of the system. It is the smallest number of independent variables that must be specified in order to define completely the remaining variables of the system. Okay, so ibig sabihin, ito yung pinakamaliit na number ng independent variable na dapat na ma-identify natin para ma-identify natin yung iba pang remaining variable sa system natin. But take note that it is specifically mentioned that this is the number of intensive variable. So we are not just talking of any variable, but we are talking about intensive variable. Katulad ng definition natin dito, the number of intensive variable that must be defined to determine the state of the system. So ito yung magsasabi sa atin kung ilan intensive variable ang dapat na alam natin para ma-define natin kung ano yung overall state ng ating system. So, para maintindihan natin, let us explain kung ano ba yung mga ginagamit nating term. So, sabi natin kanina, yung degrees of freedom is the number of intensive variable to be defined, no? So, ano ba yung intensive variable? So, meron tayong dalawang forms of variables. Meron tayong tinatawag na extensive variable. Ito yung mga variable na dependent sa quantity. So, ano-ano ba yan? Volume, mass, number of moles, and others, no? So, dependent siya sa quantity ng ating material. For example, we have 1 jar of particular material and we have 2 jars of particular material. So, nagde-depend tayo sa quantity ng ating material, no? Yun yung ating mga extensive variables. So, yan nga yung volume, mass, number of moles, and others. And ano naman yung tinatawag nating intensive variable? These are the variables that does not depend on quantity. So, hindi siya naapektuhan ng quantity natin, katulad ng temperature, pressure, density, no? So, for example, we are talking about water. So, yung water, ang density ng water na nasa baso is the same na density ng water na nasa timba. Kahit mas malaki pa yung volume niya, pareho lang ang ating density. Provided they are both at the same temperature and pressure. So, yan yung mga tinatawag nating intensive variable. Okay, extensive is dependent on quantity and intensive variables are not dependent on the quantity. So, ang sabi natin, the degrees of freedom is the number of intensive variables to define in order to determine the state of the system. So, yung degrees of freedom ang magsasabi sa atin kung ilang number of intensive variable ang kailangan natin para ma-determine natin yung state ng system. So, ano ba yung tinatawag nating state? The state is knowing all the variables in the system. So, alam mo na lahat ng variable natin sa ating system. So, that will help us to define kung ano yung state ng ating system. So, it includes lahat ng ating variables like volume, mass, number of moles, temperature, pressure, density, and others, no? But, we have to remember that phase rule pertains only to system at equilibrium. So, equilibrium refers to a state of absolute rest, no tendency to change state, no process operating or physical equilibrium, no fluxes of energy, mass or momentum, no temperature, pressure, and concentration gradients, no reaction occurring or chemical equilibrium. So, yan ang dapat nating matandaan. That phase rule only pertain on the system that is in equilibrium. So, para mas maintindihan natin, let us have some examples. No? Dito sa right side natin, we have the phase diagram of water. So, if hindi kayo familiar dito, you can watch our previous video about phase diagram. Okay, so dito natin makikita kung ano yung condition ng ating water at different pressure and temperature. So, dito sa ating graph, meron tayong pressure sa ating y coordinate and we have temperature in our x coordinate. Okay, so by combining these variables, no, meron tayong pressure and temperature. Pag meron tayong values niyan, ma-identify natin kung ano ang state ng ating water, no, on this example. So, magbigay tayo ng halimbawa, no, we have here an ice na nasa loob ng ating beaker and we have a heater, no. So, at the beginning, meron lang tayong ice. Okay, so yan ang given natin ngayon. We have an ice. So, we want to know kung ano yung state ng ating water, no, na naandito ngayon. So, according to Gibb's phase rule, the degrees of freedom is equal to the number of components minus the number of phases plus constant 2. Diba? Yan yung formula natin dito. F is equal to C minus P plus 2. So, yan. Sinulat lang uli natin. So, let us try to identify, no, para malaman natin ilang degrees of freedom ang kailangan natin for ice. So, in here, isang component lang meron tayo, water. Okay? So, that means our C is equal to 1 because we only have one component on this example. Minus phases. Okay, so ilang phase meron tayo dito? We have only ice here. So, isang phase lang tayo. Now, we have solid phase. So, we have one phase, then plus 2. Okay, so let us solve for the degrees of freedom F. So, 1 minus 1 is 0 plus 2. Therefore, our degrees of freedom is equal to 2. So, what does it mean? Para ma-identify natin yung state ng ating ice, we need to have two intensive variables. Diba? Yan ang definition natin. It's the number of intensive variable that must be defined to determine the state of the system. So, sabi dito, we need two intensive variables para ma-identify natin yung state ng ating ice. So, let us have a look at our phase diagram here. So, we know that ice is in solid state. So, nandito siya sa ating solid state. So, as long as nandito siya sa ating solid region, we need two intensive variable para ma-identify natin yung state niya. So, pressure and temperature are intensive variables. So, let's say the state of our ice is right here. So, para ma-determine natin yan, we need two variables. Ano yun? Pressure and temperature. Nakikita nyo to, guys? Ibig sabihin, kailangan natin ng dalawang variables, temperature and pressure, para ma-identify natin tong location na yan. Let us have another example. Let us say, given sa atin at 1 atmosphere, so, we have here already, no, 1 atmosphere, and sabi we have negative 30 degree Celsius. Okay, so, if we connect that, sabi yan daw kasi yung condition ng ating ice. So, if we connect that, we will arrive at this point. So, that means this is the state of our water. And para ma-identify natin yan, we needed two variables. Okay? Intensive variables like pressure and temperature. So, the same way naman, if, for example, you have 2 atmosphere and you have negative 40 degrees Celsius. So, pag pinag-connect natin yan, okay, we will arrive at this point, for example. So, it takes two intensive property to identify kung ano yung state ng ating water at this example, di ba? So, yun ang ibig sabihin ng degrees of freedom equal to 2. Para ma-identify natin yung state niya, we need two intensive variables. Now, let us have a look at this. So, dahil ininit natin siya, na natunaw yung ibang ice natin. So, now we have ice and water sa example na to kasi we are heating our sample na nasa loob ng beaker. So let us use again Gibbs space rule. So F is equal to C minus P plus 2. So F is equal to, ilan ang component natin? Still 1. Water pa rin ang pinag-uusapan natin dito. So our component is equal to 1 minus, ilan ang ating phase? Now we have ice and water. So we have phase 2 and plus 2. So F is equal to 1 minus 2 will be negative 1 plus 2 will be positive 1. So we only have 1 degree of freedom, no? So that means we only need one intensive property. So paano natin yan ma-visualize dito sa ating phase diagram? So kung makikita ninyo itong ating red line, this signifies that this is the boundary between solid and liquid. And on this line, we have a presence of liquid and solid water. Okay? So it is understood that it is on this area. So let us have a look. Now we have ice and water. Okay? So that means it lies somewhere dito sa ating line na red, no? Because this is the boundary between solid and liquid. So let's say, isa lang daw ang kailangan nating intensive property. So how are we going to use that? For example, ang given natin na intensive property is pressure na 1 atmosphere. So is it possible to determine kung ano yung state ng ating water dito sa condition na yan? Yes, because we know that it is somewhere on this red line. So if we are going to extend our line, so let's say 1 atmosphere and we extend it here, from there we can identify kung ano yung temperature niya. We just need to move this downward. Then we can determine kung ano yung temperature niya, like 0 degrees Celsius for example. So isa lang yung kailangan nating intensive property. And we can identify the other properties, di ba? Now let us have another example. Paano naman kung ang given natin is temperature, like for example, negative 30 degrees Celsius. So if this is negative 30 degrees Celsius, alam natin that this red line is the boundary between solid and liquid. So since we have here two phases, so we will just extend this. Okay, at kapag tumama na siya dito sa ating curve here, which is the red line here, we can now extend this to get the pressure. So kung ano man yung pressure na makukuha natin dito, like 1.5 atmosphere, so na-determine na natin kung ano ang state ng ating water just by knowing itong temperature natin, no? So isang intensive variable lang ang kailangan natin, ma-identify na natin yung state ng ating system. Okay, so now let us have another example. So pinagpatuloy natin yung pag-iinit ng ating sample hanggang ang natira sa atin is water na lang. Liquid, I mean. So liquid water na lang ang natitira sa atin. Now let us use again Gibbs space rule. So F is equal to C minus P plus 2. Okay, so F is equal to, ilang component meron tayo? Still the same. Water lang ang pinag-uusapan natin. Minus, ilang phase meron tayo? Isa lang. We only have liquid water now here. So 1 plus 2. Okay, so F is equal to 1 minus 1, 0 plus 2 will be 2. Okay, so kailangan natin ng 2 intensive variable. So, katulad ng sa solid kanina, no? Dalawang intensive variable ang kailangan natin. In this case, we have pressure and temperature. So let's say our pressure is 1 atmosphere and our temperature is 80 degrees Celsius, somewhere here. Okay, so our pressure is 1 atmosphere. So if you're going to extend that and extend itong ating temperature, it will meet here. So we are able to determine kung ano yung state ng ating water. We know that it is in liquid form. Okay, so para ma-identify natin kung ano yung state niya dito sa ating phase rule, no, dito sa ating liquid region, we need two intensive properties. So kailangan natin ng dalawang values ng ating intensive property, which is pressure and temperature on this case. Okay, so ganun din katulad nung nasa solid form kanina, no, or solid state, kailangan natin ng dalawang intensive variable. So ganun din naman dito sa liquid, kailangan natin ng dalawang intensive variable. So let's say our temperature is 60 degrees Celsius and our pressure is 1.5 atmosphere. So we are going to extend this and this until they meet here. So as you can see, kailangan natin ng dalawang intensive property para ma-identify yung state ng ating water. And that's what it means here. We have 2 degrees of freedom. Okay, so tinuloy natin yung pag-iinit. Now it start to evaporate, no? Nagbo-boil na yung ating water, so nagkaroon na tayo dito ng presence ng liquid and vapor. Okay? So, now in our phase diagram, as you can see here, this boundary, okay, this blue line is the boundary between liquid and water vapor. Okay, so that means on this line, we have the presence of both liquid and vapor. Okay, so which is our case now here. So again, let us use our Gibbs space rule, which is F is equal to C minus P plus 2. So F is equal to our component. Ilang component meron tayo? Still isa pa rin, water pa rin naman yan eh. We have vapor and liquid water, but this is the same component. We have water. 1 minus ilang phases meron tayo. So we have vapor, which is a gas phase, and liquid phase ng water. So we have 2 and plus 2. So 1 minus 2 is negative 1 plus 2. So our F is equal to positive 1. So that means our degrees of freedom is equal to 1. So isa lang daw ang kailangan natin. So how are we going to show that dito sa ating diagram? Let's say we have a pressure of 1 atmosphere. Okay? So if we're going to extend that until dito sa ating blue curve, because this is where we have the presence of both liquid and water vapor, di ba? So once it touch our curve here, we can extend that papunta sa temperature, and we are able to determine that at 1 atmosphere and the water is boiling, so we have now here the presence of water in liquid form and in vapor form. It will be on this curve. So kapag in-extend natin to downward, we will have 100 degrees Celsius at temperature. So as you can see, ang meron lang tayong detail is yung ating pressure, which is 1 atmosphere, and we are able to determine kung ano yung temperature ng ating liquid at that point. So as you can see, kailangan lang natin ng isang intensive property in order to identify the other variables. So if we have 1.5 atmosphere, we are just going to extend that papunta sa ating curve, okay, our boundary between the liquid and the vapor, and then extend this downward, we will be able to get our temperature. Okay, so ganun yun guys. Makikita ninyo, isa lang ang kailangan nating intensive property to identify our system, no? Now, tinuloy natin yung pag-iinit hanggang naubos na yung ating liquid water. Ang natira na lang is yung ating vapor. So now, we will be talking about this region here, kung saan wala nang liquid water, ang natitira na lang is yung water vapor. Okay? So, use our Gibbs space rule, which is F is equal to C minus P plus 2. So, F is equal to our component is still 1. Water pa rin. Minus our phase, okay, ang available na lang dito is vapor, water vapor, which is 1 plus 2. So, our F is equal to 1 minus 1 is 0 plus 2 will be 2. So, we have a degrees of freedom of 2. That means, kailangan natin ng dalawang intensive variable. Okay? So, gusto natin ma-identify yung state ng ating water dito sa ating phase diagram. Kailangan daw natin ng dalawa. So, let's say we have a pressure of 1 atmosphere. So, if we are going to extend this, makikita mo that you cannot identify kung ano yung state ng ating vapor unless alam mo kung ano yung ating temperature. So, let's say our temperature is 150 degrees Celsius. So, only by that, we can identify kung ano yung state ng ating water. So, now it is on this section. As you can see, kinailangan natin ng dalawang intensive variable para ma-identify yung ating system. So, that's what it means by Gibbs space rule. it tells us kung ilang intensive variable ang kailangan natin in order to identify kung ano yung state ng ating system. So I hope you understand our lesson, and we will be showing more videos to you for our physical chemistry, chemical engineering calculation, and thermodynamics. But that's all for now, guys. Thank you very much and have a nice day.